Hey guys, I'm going to do a brief overview of what we went over in class, just try to refresh the scientific process that we did. I'm going to try something a little new here with paint that I've never done, so bear with me if we have some technology difficulties here. You can see that this is the blank science process map that we did draw in class. I'm going to try to fill it in. Um, Remember what I talked about and most kids or most of you guys have learned about the scientific method in the past. I am not a huge believer in the scientific method as it makes kids think that there is a set way to do science. And science itself is an evolving thing. It's always changing. There's no one-step timetable to finish everything. But there is a process in what we do. It's not necessarily a five-step easy system, but it's something that, okay, we've done this, we'll move on and continue to build and grow on our ideas or our questions and concerns. So whenever we're deciding what we want to figure out, you always want to start with a problem. Okay, there's always something that we want to figure out, that we have a problem or a question. You can see that here as it's typing. There we go. It's typed in there now. See if I can make this a little bit bigger. Sorry, bear with me. I always want to start with a problem or a question. And like I said, technical difficulties here. Hold on, I'll be right back. Okay, sorry about that. Had to get that fixed. We're good to go now. So we wanted to start with a problem or a question. And that's just something that we're interested in figuring out, or that somebody's giving us a grant to figure out, or your teacher's saying, here's an issue, figure out how to solve this problem. And that happens in everyday life in science. So once we identify what our problem is, we want to, get out there and start the scientific process itself. So what I would say moving on forward, the next thing to do would be to observe what we're trying to figure out. So the example that I gave in class, the leaves changing colors, in order to figure out why that happens, you probably need to go observe some leaves changing colors. Okay, we need to look at different samples, look at some trees that don't change colors. We probably need to do some leaf dissections, things like that, chemical analysis on these things and figure out why these things happen. We want to go observe these things in nature in their natural habitat and figure out what we can. Next step after that, and sorry, I'm hesitant to say step because that makes it sound like the method, but we have all this data that we've compiled from our observations, and it's time to interpret our data. Sorry, I'm trying to do two things at once, talking over this and typing at the same time. It's not so great for me. The interpretation of our data is where we compile all of everything, all of our observations, all of our graphs, everything, into something that we're getting ready to formulate an idea and decide why we think what happens happens. So the logical move forward after that is the statement of why we think what happens happens and what's going to be the end result of our problem. And we call that the hypothesis. Okay. Let's make this a little bit bigger so you can see it. Okay, and there's a lot of teachers that you've had. There's a lot of teachers that you have had that will say that your hypothesis is an educated guess. And that's what I hear students say quite frequently. However, I don't believe that that is an accurate representation of what a hypothesis is. So we've already done all of these steps here, all of these steps. And so I don't feel like when we get here, we're making a guess. So I'm going to define a hypothesis as a proposed possible answer or solution to the question. Because at this point, these steps here, these could take years and years and years to accomplish. And after I've been doing this for so many years, I don't feel like I'm guessing anymore. I feel like I've done my research, I've done the observations. I'm answering the question with this statement. So, after we have formulated our hypothesis, that's everybody's favorite thing to do, is to test our hypothesis. And we call testing a hypothesis experimenting. We can make this a little bit bigger as well so you can see it. So after we finish our experiment, we're going to come to a conclusion about what happened. And in this conclusion, we're going to decide whether our hypothesis was correct or it was incorrect. And so these are the next two steps. If our hypothesis was correct, we're going to confirm our hypothesis. Notice that's an arrow going back to experiment from confirmation. That's because one of the biggest things about science is that your results need to be reproducible, which means that you have to be able to do them over and over again, and you have to take such detailed care in doing it that anybody can replicate your results. If not, how are we going to know that what you're saying is actually true? So after you confirm your hypothesis, you need to go back and experiment, and keep experimenting and keep experimenting. Okay? If your hypothesis was wrong, if we were wrong at the beginning, chances are we have a better idea of what we're going to try to figure out or what the correct answer is. And so we're going to go back and reformulate our hypothesis. So here we have rejected our hypothesis. And you see this fills out the map. After the hypothesis has been put through the ringer, we move on to different steps of what a hypothesis becomes. A hypothesis will eventually become a theory after it's been proven several times over. And the formation of a theory takes years and years and years and years of experimentation and testing and study. It doesn't just become a theory overnight. So the slang term or the common vernacular of saying, I have a theory about this, you actually have a hypothesis, or you have a guess, or you have an idea. Okay? The formation of a theory takes years. After a theory has been proven beyond a reasonable doubt, and it is what's going to happen every single time without fail, it becomes something called a law. Okay, so you can see here how all of these things connect. This is my presentation on the scientific process. Let me know if you have any questions.